As I was saying, my dean is one of the best deans I know. Sorry. Okay. So just to catch everybody up who's not here. I mean, you guys have all this written down, yes? This does feel like a lot. More than likely because it is. But there are all these things. You could either straight up memorize all of these, or you can notice, I only need to know one thing, and I can build the other things. I only need to know one thing, and then I can build the other things. Okay, maybe. These, of course, lead to these. If I make both of these theta, I end up with this, for example. Yes? What's the newest ones that we know? Yeah. It's a cube, that's all right. Plus or minus square root. And the only difference with cosine, of course, cosine is an asshole, so he took the plus sign for himself. That is a stretch, and I don't care.
Stole the plus sign.
Yeah, he did. He's like, I get the plus sign. Sign's like, whatever, man, sounds good.
Sign just goes with the
Okay. This does seem like a lot, but again, it's because it is. But you have to know these. Every single one of these can show up in Calc 1. Almost every single one of these definitely shows up in Calc 2. So even if you're just taking Calc 1, any of these can show up anytime. They definitely, by design, because they're related to things we're learning, almost all of these show up in Calc 2, no matter who you take. Calc 1, you could get lucky and take somebody who puts very little trig in it. But to me, that's evil, because then Calc 2 requires so much trig, people forget it, and then they hit Calc 2 like a brick wall, yes? So when I teach Calc 1, I infuse a lot of trig into it to keep the trig alive, because Calc 2 is going to eat you alive if you don't know your trig. I'm evil, sorry. You guys know this. Yeah, I'm like cosine. I'm worse than cosine.
And you're teaching Calc 2 this semester, right?
I'm teaching Calc 2 next semester.
Yeah.
Yeah.
So you won't teach it for that long.
Yeah, I don't know yet.
We never
Depends.
know. Oh.
Yeah.
Cool.
He's gonna wait.
I was like preparing for that.
No, I mean, there's, yeah, other teachers here are great. You should take them. What do you think? Did I bring any blank paper? No. No. So there's that. And then the last couple that you have to memorize, which is so fantastic. This one's nice, yes. Did anyone else have anything else besides these? Did everybody have some of these? Is there anything I haven't listed yet that somebody had? All right, here's the other ones.
Oh, water sign.
Oh yeah, I knew that one.
No.
That's counted, yeah. And then of course, does anyone know the law of cosines? I'll get it started. I do my Pythagorean theorem, yes?
Yeah.
But then it says,
Minus cosine.
not at first.
AB cosine C?
Close.
2.
Oh.
Okay.
Yeah, very obviously there's a 2. No, it's not obvious. So we did do this together. We did derive this equation together. That doesn't mean that any of us remember how the hell we did it. But I love it. There's the Pythagorean theorem, and it just says if you're not a right triangle, there's a little bit of an adjustment. If C is 90, what's this term become? If C is 90, angle C is 90, what does this term become? What's the cosine of 90?
0.
0. Cosine like x, 90 degrees is all y. So if C is 90, why does that make sense? Because when is Pythagorean theorem actually true? A right triangle, 90-degree triangle, yes. So this still jives with c squared equals a squared plus b squared for right triangles. It's just more general, yes? Okay. Again, you don't have to love this, but when I first learned this, my little tiny Jeff mind blew. Because I'm like, that kicks so much ass. That's like a little adjustment. Oh, poor little triangle. You ain't quite right. You still do something. Okay, maybe. How we doing? I know I have a very strange way of looking at math. It's okay. So you do have to know all of this. And I didn't do this to make you feel overwhelmed. I wanted to remind you that you can remember one thing and then build from it. Yes? If you remember something, you can build from it. If you can remember these, you can replace A and B with theta and recover these. Yes? So you don't have to memorize all of this. Maybe.
What would happen if that was A for law of cosines?
Oh,
It will be A squared equals C squared minus B squared?
No.
Why me?
huh?
Because the original equation is A squared plus B squared equals C squared, right?
True. And that's because we normally, in a right triangle, C is always the largest angle.
Yeah.
This is saying you might have a triangle where you just arbitrarily call A the largest angle.
Oh.
You might not even know it's the biggest, you just happen to call it A. So this has to still be a potential thing. You with me?
Okay.
I mean, even in the Pythagorean theorem, A, B, and C are arbitrary. We just kind of said, why don't we make C always the hypotenuse, right? We didn't have to do that. It could have been this. And of course you could have, but notice, you guys notice the similarities though? Whatever letter's here is absent here. Yes? Whatever letters are here are also here. And whatever letter's here, its angle goes here. I mean, that's what stays constant. These, to my math brain, these are all the same three things. Because A, B, and C are arbitrary. If I change the labels change what they do. I see all three of these as the same. That's why I only wrote one, because that's really all you need. Okay. All right. So trig is challenging. But I feel like we've built a decent foundation. I know the identities are troubling. It's one of the last things we work with. We might not have lived with them as long. So maybe they didn't stick as well. But I feel like if I ask you guys, what is the sign of pi over 3? Can you give that to me within like 10 seconds? Can you think about that and give me the value?
Pi 3 over 2.
Why? I'm sorry. I have to share with you what Anas did. Anas went,
No, I went like from 0 to 60 and it's at 60.
so what is sine like? Sine likes y. So it's going to be bigger when you're closer to the y-axis. Pi over 3 is 60 degrees. I'm really close to the y-axis. I should be the bigger of the 3 in the middle. Let me make sure you guys are cool with this.
Mm-hmm.
This is 0. This is 1. The 3 in the middle are 1/2 rad 2 over 2, rad 3 over 2, yes? So if I am closer to the y-axis, sine should be the bigger. If I'm closer to the x-axis, sine should be the smaller. If I'm right in the middle, rad 2 over 2, that's where they both agree. Okay. I like it, I like it. Okay. Then I wanted to go, now the weird thing is, I kind of wanted to jump back. But we can, all right, I'm gonna open it up a little bit because I wanted to jump back a little ways. But does anyone want to do any other examples right now of the identity stuff? We could do like the solving a triangle problem on the practice final. We could do a application of law cosines. We could do, what was the other thing I was just thinking? What I really wanted to do was focus a little bit of time tonight eventually on factoring, because it's been a minute since we just straight up factored stuff. And factoring is huge. It's everywhere. So, let me ask you guys what you think. We could right now, based on what we just did, didn't I didn't. That's weird. Yeah, one kind of problem I left off here is like solve the triangle problem. I thought for sure I put a problem like
Just
that.
solve the triangle.
The L number 13, solve the triangle.
Oh, like this guy, here he is.
It's
Yeah.
just the law of signs.
My poor unlucky number 13 that got, not only shouldn't he be number 13, he's like.
We're just having no space to do anything with.
So can you guys take a moment? Has anyone tried this problem out yet?
I already did that.
You already did it? Okay, just sit there for a second. Can you guys figure out, don't say anything, if this is gonna be law of sines or law of cosines? Can you try to draw the triangle for yourself? And then determine if this will be law of sines or law of cosines? Do you notice something about law of cosines? If you only know one side, could law of cosines work? Because then you'd have more than one unknown. You don't have any way to set up an equation that's got only one unknown, right? But even beyond that, what's the easiest thing to get? So obviously I kind of gave away the game here. This is going to be law of sines. But what is it that tells you it's law of sines? What are you supposed to be able to set up in order for it to be law of sines?
The ratio?
A complete ratio.
Yeah.
If you only look at what I've directly given you, you cannot do that. But of course, what's the most immediate thing you can figure out?
The degrees, the other.
Yeah, I can get the other angle. If I got two angles, I got the third angle. Then I can make a complete ratio in B. So, you don't have to memorize this, but doesn't it make sense? Law of cosines. If there's only one side I know, every possible equation is going to have two unknowns. Can't do that. I need one unknown and I can solve the damn thing. So there must be a way for me to use the law of sines for this, and sure enough, I can get angle B.
59.
What is it?
59 degrees.
59 degrees? Oh my god, I can't see anything. Yeah, cool. And then you can set up the ratios, yes? So I think y'all agree with me. Law of sines is really nice except for one thing. It's not going to happen here. What's the one thing that could happen when I use law of sines? Potentially.
AAS.
Almost. More directly. You said AAS?
Oh, ASS.
ASS.
Oh,
Yeah, B.
Yes.
It's
I
not
told my-
AAS.
I
It's
told my
just
coworkers about it.
Oh yeah?
Everyone was like, ask Ryan.
It only makes sense to me. In the high school, the teachers don't want to say, they say SSA. You know what I mean? And I'm like, no, just call it ass, because it is. It's an asshole. Why can that not happen? Can anyone see why that's not going to happen here? Can anyone see why that cannot possibly happen?
There's one side. We got all the degrees.
We have all the angles. There's no way one of them can be different because we know what they all are,
Oh.
right? We know what every angle is. So there can't be another triangle. There's just this one. Yes?
By the way, what's the ass there for?
Angle, side, side.
Okay.
Yeah. I like that. Hey, Dean.
Sorry, Dave.
You're good. Did one of your students ask you what I asked them? Yes, they did. Do you not know math? All right. Do you guys want to do that?
Yeah.
Corinne's like, no.
Corinne's getting out.
We should do law of cosines instead.
Yeah, I can make a lot of cosines problem.
Yes.
So real quick. What would be the first step on this? Just the first step.
Set up the B ratio.
Yeah.
Sin 59 over 5.
Good. So that's the B stuff. Now, I would highly recommend that you find a larger angle first. Well, it actually doesn't matter, Jeff. You're being overly careful. It doesn't matter what you find next. So if I wanted to find A, side A, yeah, I just realized I'm being way overly cautious. And now I just solve for A, right? I don't have to do inverse sine because I already know all the angles. There's no angle to solve for. Okay. And then you do the exact same thing. Instead of 23 degrees, I would put 98, and then I could solve for a little c, yes? How do I solve this kind of equation? Cross multiply, yeah. Yes, sir.
How come I couldn't just multiply sine 23
By what?
by sine 59 over?
Real quick, I really appreciate you asked that question because I get people do this all the time. And what you're not doing is thinking about the math that gets you there. So if I multiply this side by sine of 23, I have to also multiply this side by sine 23. Do you see how that's not going to cancel? It's going to make it squared now. Sine 23 times sine 23 is sine squared 23. You'd have to divide. And the really sucky part about this whole equation is our variables on the bottom. That's why cross multiplying makes a lot of sense because it gets our variable unstuck, gets it up top.
Okay.
Good. So let's make up a law of cosine. So I'm kind of giving away, this is going to be cosines. I want you to tell me why it is. Let's say that A is, I got to make one that actually works, that'd be great. 11 centimeters. Let's say that B is 3 centimeters. And let's say that angle C is, what do you got, Jeff? Give me a second, Jeff. Angle C is 49 degrees. Can you guys draw that? It doesn't have to be perfectly to scale, but you want to try to make side A big and side B smaller. Where is angle C relative to side A and side B? In the middle. Kick ass. I had as much room as I wanted to, and I shoved it all in here. Okay. So why will law of sines not work? Yeah, I can't make it complete. I don't know angle A, but I know side A. I don't know angle B, but I know side B. I don't know side C, but I know angle C. I can't make a complete ratio. So again, the same problem as before. I would have too many variables in any equation I try to set up from law of sines. So then law of cosines will hopefully allow me. Yes? Do I have at least two sides? Yes. So law of cosines should have a better chance of working. And sure enough, the two sides I know are exactly the sides that go with this angle. I don't know if you guys are understanding. So which law of cosines am I going to use? Which formulation?
C squared.
Yes, the one that starts with C squared. Because I can get side C from angle C. So if I start with side C, then I got my normal Pythagorean theorem minus what?
2AB cosine C.
Good Lord, Jeff. Okay. Cosine. Okay. Oh my gosh. I feel really bad for you guys. I'm always so tired. All right. So now if I shove everything I know in, there's only one thing I don't know in this equation. That's side C. Yeah. And the biggest mistake I see with these kind of problems is, well, first off, I see people not doing order operations correctly. But this one, I can just throw all of this in the calculator and it knows order operations. So I should be golden. So I feel pretty good that you guys are confident in how to tell when law signs will work and when it won't. And any problem I give you, if law signs won't work, law cosines will. In the real world, we have to make sure we get enough information for anything to work. But I'm always going to give you enough information for one of the two to work. Okay. So if I shove all this stuff in, see A is 11, B is 3, 11 and 3, and C was 49 degrees. Now I can just shove all that in the old calculator. Look at C squared is just out of here at 130 minus 66 cosine 49 degrees. So if you just shove that in the old calculator, it's going to be a little less than 81. C's almost 9. That's weird. Okay, let's see what we get. So just to make sure you understand, you don't have to do any of what I did here on the last part. You can just literally put in your calculator 11 squared plus 3 squared minus 2 times 11 times 3 times cosine 49, and real quick, make sure I'm in degrees. I am. Enter. Now, why is that not my answer? Good. So C squared equals that, and so if I square root that, I get 9.311. Aha! Now, am I done? No. Hell no. What do I still have to figure out? Huh?
Oh, you have to figure out the other angle.
Yeah, the other angle. So the things I don't know still are angle A and angle B.
Now you have
What am I allowed to use now, though?
laws.
I'm allowed to use law of sines because I just completed the C ratio. Yes?
Mm-hmm.
Now, my answer is going to be a little off because 9.311 is an estimate. I don't care. I'm fine with that. Right? If you round to like 3 decimal places, it really shouldn't throw you off that much. Is that, you guys with me? Do you guys see that? Once we do law cosines once, I now have a complete ratio I can make. I could switch to law of sines. Here's the one bad part though. Are we about to solve for angles? Yes. Which means I'm going to take an inverse sine. Which means the answer could be a reference angle and not the actual angle. Can anyone tell me what angle should be the biggest in this triangle? Because its mouth's got to open the most, yes? It's got the biggest stick in it, yes? Let me see if you guys are with me on this. If I'm ever going to do law signs, I want to do law signs using the biggest angle first. I need this to make nothing but sense. The issue for taking inverse sine comes into play when I get a little angle and then I have to do 180 minus that to see if it fits into a second triangle, blah, blah, blah. There should be no second triangle here. There cannot be a second triangle. But if so let's see, let me see if I can get you guys with me on this. If we do, I got my C stuff. That's my C stuff. Angle inside. And now if I do A, I can multiply by 11, take the inverse sine, let's see what we get. Where'd it go? Inverse sine. I think I'm thinking about this backwards, which is hilarious. Am I? I might be okay. So this would be 63, and that would leave, which one do I not know? B. Yeah, I think I did this. It's okay, Jeff. I might have thought about this backwards. So can angle A, so if A is 63 degrees, what would angle B be? Does that work out okay? Yeah, see, that's no good. Huh? What's up? What'd you get?
70 something.
How'd you get 70 something?
I'm just doing some math and I don't know.
Oh, okay, okay. Oh, okay, almost. It'll be 68.
Oh, 68, okay.
Now. Alright. Please forgive me. I think I thought about this backwards. So real quick, when I take an inverse sine, what's the biggest output that I can get? What's the biggest output for inverse sine? Does anyone remember? We had to chop sine to make an inverse exist.
What did you say?
The biggest output I can get for inverse sine. 90, you guess. Pi over 2, 90 degrees. Because I had to cut from negative pi over 2 to pi over 2 to make the result actually invertible. To make it pass the horizontal line test. So I was thinking exactly backwards about the same problem. I'm thinking about something else, I'm not sure what it is at the moment. I should have done the smaller angle first. If the biggest angle this could give me is 90 degrees, and I have an angle in my triangle that's bigger than 90 degrees, can it give that to me? No, it'd have to give me a reference angle. Yes? Okay. So this is actually a reference angle. What should the biggest angle be in this triangle? A has to be the biggest angle.
Yeah.
If A is 63, B is 68. Does that make sense? No. So this is a reference angle. I really want you guys to understand why that's just a reference angle. Inverse sine can only give me up to 90 degrees. So if the answer is supposed to be 150 degrees, inverse sine will tell me 30. Because that's the reference angle for 150. You can't get there, it would give me a reference angle, which is the next best thing. Why is it not its fault? Because we had to chop it to even make it exist in the first place. Okay. I'm trying to remember which. Oh, that's okay, John. So what I should have done here is I should have solved for the smaller angle first. Because then that would have just been straight up the right answer. So real quick, let's do this. What's 180 minus 63? Yes. So this should be, so A should be 117. C we already know is 49, so what's left over for B then? You can do it. What do we have so far?
14 degrees.
Yes, 14 degrees. Yeah. Does that make sense? Yes. B should be really tiny because its mouth is so tiny. So if you guys will continue to be patient, if I would have realized that sooner, what I should have done is solve for the smaller angle first. That's the one inverse sine would not have to give me a reference angle for. It would just tell me. Let's see if I get what I'm supposed to get if I do this for B. So that would be, let me see if you guys are cool with this. I would multiply the 3 up and then take an inverse sine. And then to do that in the calculator, what I can actually do is pull this guy back up and change the 11 to a 3. And I get 14 degrees. Yes?
Yeah.
Okay. I'm not sure why I was thinking about that exactly backwards. There's a different situation where it's smart to do the bigger angle, but obviously not this situation. Okay. Okay. So one thing to notice, if you have to start with law cosines, you can shift to law sines once you get one more angle. Or one more side, because then you can make a ratio. Yes? You can use law sines anytime you're able to make a full ratio. So, I kind of either wanted to look at factoring just because it's been forever. Or I can talk about more trig stuff, although I feel like maybe we could use a break from trig stuff for
Yes.
Okay. So, has anyone tried these?
Mhm.
Anybody? Anybody else? You guys?
Um,
If you tried these, which one was the hardest? Or which one do you think you might not have gotten right because you're not sure about it?
C.
C?
Mhm.
Okay. If you haven't tried these yet, the C looked like it would be weird. Okay, so let me do this. Can you guys try C out, and I will give you one hint. This helps with Part B also, and Part D. Part B, C, and D all have this. What is it you always try first? GCF, kick ass, because GCF will either be the only thing you can do, or it leaves something easier to do. So what can come out of all three? Do that first for 14C. Go for it. I'm gonna find some paper. I don't think I brought any paper. Oh. So the first step is always GCF. The next thing you do is determined by the number of terms there are. If there's two terms, it could only be one of two things: squares or cubes.
Yep.
If it's four or more terms, it's probably grouping, yes? And if it's three terms, after I do a GCF, I try to do the trial and error thing. Or you can do the surefire method. So let's see, what comes out of all three?
W squared.
Kick ass, what's left?
Oh, yeah, that's a better way to say it. W squared. It's 28.
Cool. Now, some people will stop there because you're like, I did something, leave me alone. But the middle term, we talked about this before. Do you see how the middle term power is half of the first dude's power? That tells you that the next step might work. We're used to seeing stuff like x squared here and so forth, right? And then you make xx. So here, what am I going to put when I do my two little...
W squared.
Yeah. And now we still have to figure out the numbers that make it work. But notice why the middle terms has to be exactly half the first dude, because I'm going to cut this dude in half, and these are going to go into what makes the middle dude. So if that was 10, this better be freaking... If that was 10, this better be 5. Yeah. Do you guys see that? If that was 10 and this is 6, we're screwed. So what numbers work?
-7, -4.
Yeah, -7, -4. One of those two you can do for sure. You can do something more with one of those two.
The W squared minus 4.
Yeah. How can you break him up?
Oh, the W minus 2 and the W plus 2.
To be really honest, there's the word. You could do this. In fact, let me just freak you guys out. Just part of my job. What the shit? This would be, now this is acceptable. This is fine. If you give me this answer, little tears for you. This, it's exactly the same thing we did here. Where'd 2 come from? Square root of 4. So how did I factor this? I can factor this as W minus half of 7, W plus half of 7. Half of 7 multiplicatively, right? Does that look good? No. So I wouldn't write that if I were you. This is fine. Go as far as you can while maintaining whole numbers. That's fine with me. Or not even whole numbers, rational numbers. There it is, John. Do you guys remember how squares work? Huh? Do you remember how squares work? Like, for example, how do you factor x squared minus 81?
X plus 9, X minus 9.
Is that cool? Yeah, that kicks so much ass. So watch this. You ready? 4w to the 10th, z to the 16th minus 25a to the 8th, b to the 12th, c to the 4th. Okay. Factor that. These problems are the same. These are the same problem. Now, I understand somebody out there has to be thinking, my dear God, did this dude forget his meds? We all know you, Jeff. There are many meds you should be on, and I think there's some meds you forgot. How many terms are here? No. How many terms are here? 2. How much stuff is in each term? Shit ton. Yes?
Yeah.
Why was this so much easier? Because x squared is just x times x. But what did you do to x squared? You cut it in half. And you cut 81 in half multiplicatively, yes? That's all squares is. I don't care a shit how much stuff there is. If you can cut everybody in half multiplicatively, and it's subtraction, you can factor the thing. So what do you get when you cut this in half? Multiplicative. What do you get? 2, W5, Z, 8. So I just write the exact same thing over here. Because now when they multiply together, they make a whole one of these. Yes? What goes in the middle? What goes here? What's the sign? Minus plus. That's always the same idea because then the middle terms will cancel. There's not supposed to be a middle term. And then I just cut this guy in half.
5, 8 and a 4, and 6, c to the square.
And then I just write that again. There's the other half of it over here. I left myself so much room. So when I do the middle terms, minus 10 blah blah blah, plus 10 blah blah blah. All the blah blahs cancel out. I don't have a middle term. I need you to see that. This is a very like Yoda moment, like size matters not. So it doesn't matter how much shit I throw in there. If I can cut it so thank you for that. That was dumb, but I appreciate you. If I can cut everything in half, there's 2 terms, it's a squares. Period. And it's gotta be easy. I just put a lot of stuff in there. You can just cut each one in half. What do you do? Okay, maybe. Maybe. What about, how does cubes work? What was weird about cubes, or what was not weird about cubes?
This so the small guy, big guy.
Yes, okay. 2 terms. If I ask you to factor, first thing you check is GCF. No GCF here. If there's 2 terms, it can only be cubes or squares. If there's no GCF. So what obviously makes this cubes? What 2 things? There's a cube. And 27, you can cut it in thirds. Yes? 2 terms, everything can be cut in thirds. It's cubes. The absolute biggest mistake I see with this is people will tell me the answer is W plus 3, W plus 3, W plus 3. Can you tell me really quickly why that makes no sense? There would be a bunch of freaking extra terms. So then maybe somebody go, well, what if I make both of these minus? There's still going to be a bunch of extra terms. So that's not going to work. So the only way it can work is what, I think Kelvin, you said this. I make, or was it Brady? One of you.
It was him.
Gotcha. One of you, either Kelvin or Brady. I make a little dude and a big dude. Is all this coming back? Because I will tell you, I definitely want to focus on factoring because factoring is everywhere. You don't understand. I can't impart to you. Factoring is everywhere. The better you are at factoring, the better you are at math, period. And you will see it when you take your calc class. So many calculus things, you do calc and then you factor. If you can't factor, you're screwed. So a lot of times I'll teach, especially when I teach 178, which is like business calc, Students will eat the calculus up, and then they have no idea. Because their algebra is a little weak, but the calc is new and interesting, so they're kind of like going with that, but their algebra is kind of weak. Are you guys all with me? So I feel as if we got to a good place with this factoring. I don't want us to lose it. It's been a while since we looked at it directly. But once it's in there, it normally comes back pretty quick. Little dude's a tiny little dude, right? What is this made of, by the way? What's W cubed? It's W times, and what's 27? You don't have to do this, but to me it's good. What goes in the little tiny poor little dude? Yeah, 1 W. Same sign. 1, 3. So instead of taking 2 X's and breaking it up, 1 here and 1 there, we're going to take 3 W's and put 1 W here. How many go here? The other 2. That's crazy. So that when I multiply it out, I get 3. So 1 W, 2 W's. So I end up with 3. 1, 3. 2 3's, 3 times 3. So I end up with 27, yes? So I got W cubed plus 27. Why did I leave room? Why am I not just circling this? I gotta make it harder, yes. Don't I also get plus 3W squared? Do you guys see that? If I just leave it this way, I can see this can't be the answer, because don't I also get 3W squared? Is that here? It's like saying you factor 40 as 5 times 9, and I'm like, you get an extra 5. 5 times 9 is 45. That can't be the right answer. I got more shit than I want. It can't be the answer. Yes? I also get 9W. What the shit? Good job, Jeff. So, it's this middle dude. It's the thing I tried to connect to the movie Pulp Fiction. You guys remember that? I don't know. That's right.
Yes.
Remember this? It's same, opposite, always positive. So, to clean up the mess in the backseat of the car, opposite sign. So what goes here?
2
Not 2,
2
just AB. 3 W. Let's see why that makes sense. Do you remember how I got 3W squared? What's W times negative 3W? W times negative 3W. Negative 3W squared. Die. Do you see how I got plus 9W earlier? What's 3 times negative 3W? Negative 9W. They die. Okay. So, 1 of each, 2 of each, product in the middle. And then I got the soap to remind you about the signs. Why does it only make sense this has to be the opposite sign? His job is to cancel the shit I don't want. So of course it has to be the opposite sign. So he can do his job. Do you guys see what I'm saying? So it's not always straight multiplication. If you see why it makes sense, it's easier to remember to do it. Okay. So here, you guys try one on your own here. Let's do 8y cubed minus x cubed. Then I think I'll open up the rest of the time to, if you have any specific questions. And remember, we got tomorrow too, so we can do more stuff. Wednesday I'm gonna go ahead and tell you this, so I do it. I'm gonna bring pumpkin bread. I'm gonna make some pumpkin bread. I make some damn good pumpkin bread, so if none of you want any, I'll be so happy. Because I have to eat it myself, so I won't take it bad if you don't eat any. But I'm gonna bring some pumpkin bread. Yes, if anybody else wants to bring anything, feel free. You wanna bring some Tupperware so you can take home some? Bring that. So the x cubed is obviously x, 8y cubed is 2y, 2y, 2y. Little dude, big dude. Little dude, buddy. So then, what goes in the little tiny dude? Good. One of each. And what goes in the middle?
Minus.
Same sign. Minus. What goes here?
Yeah, 2y squared.
Almost.
4y.
4y squared. What goes at the end? X squared. This sign is
Positive.
always positive. This sign in this case will be
Positive.
positive, opposite sign from this. And what's my middle term?
2yx.
2yx, kick ass. Or 2xy, don't matter. That says 2yx, by the way.
2 line x.
Good lord, 2yx. Now, if you have time, how do you check yourself? You can always check yourself pretty easy. You just FOIL it, yeah. Multiply it out. Okay, I like it. This semester, I tell you, this has come up so many times, and students get upset at me, and I'm like, we have talked about this. I have told you I'm going to put these on there. I've told you how to do them. So you have to know how to factor to do almost any STEM past this level. It's everywhere. Yeah. Hell yeah. Maybe. Where did I put it? Oh, there. Okay.
Oh, I have a question.
Yes.
For quadratic formula, is there like can be rules like we did like last time, like for projects, or like if you're gonna like ask us to use like complete the square, or we can use
Oh.
one?
I might specifically request a method or, yeah.
Okay.
So you gotta be a little question.
Why is it effective?
So, what do you think about 14A? Is anyone troubled by anything? Besides the fact that it exists. Are you anybody worried about like extra letters compared to normal? I love it. Some of you guys are like, dude, I didn't think about that. Here's the great thing about the method I showed you. It will make everything fall into place for you. If we focus on the numbers that make things work, the method I showed you will make everything fall into place. Here's what I mean. Can you take a GCF out of this?
No.
Yeah, right? The last term didn't have an X, the first term didn't have a Z, and this 5, 7, and 6 ain't no number going all three of those. No number that's nice to look at. Does anyone remember what to do when the first number is not a 1?
Make it a 1.
No? Because I can't take a 5 out. I could make a bunch of fractions right around.
Would you break up the middle term and then do like
Yes,
the-
but how do I get there?
Whatever, multiplies to 30 and then adds to
Yes! Alright, where'd you get 30 from?
5 times 6.
Kick ass. So when the first number is not a 1, you multiply it with the last coefficient. So I'm trying to find factors of 30 that add to be, negative 30 that add to be negative 7. Does that sound familiar to you guys? When the first number is a 1, things are so much better. Because then I'm just focusing on what multiplies to be the last dude, adds to be the middle dude. If the first number is not a 1, that dumb number is going to mess with all my middle shit, so I got to take it into account from the beginning. So I want factors of negative 30 that add to be negative 7. So it can't be like 5 and 6, right? 5 times 6 is 30, but you can't put 5 and 6. Negative 10 and 3, yes. That'll make negative 7. Mm-hmm. Now, you said it perfectly. What do I do with those?
What do you mean? I'll break up the middle term into those two.
I like that. You had a moment like, what did I say?
Yeah.
Now, real
I
quick,
backtrack.
I need you to, this is the part that people don't really get. The only way that makes this legal is if I have negative 10 xz's and 3 xz's. That would add to be negative 7 xz. Do you guys see that?
Mm-hmm.
I don't have to, do you see how I really don't care? The numbers are what I have to worry about. I can leave everything else exactly where they are. Then when I do the grouping we're going to do, all the letters fall into place. I have enough mental load on the numbers. Stupid process better figure the stuff out. And of course I left off my minus 60 squared. So I wrote the exact same thing as this. This is the same as this. This is just a better way to see it. Why is this better?
Because now you can factor by grouping.
Now I can factor by grouping. And grouping is relatively easy. What comes out of the first two? And? What number comes out?
Oh, negative, wait, hold on.
5x.
Yeah.
What I did.
5 comes out, and an x comes out. And left with x minus 2z. What comes out of these two? 3 and a z, and I'm left with 3z's gone, so I'm left with x. 6 divided by 3 is 2. Had 2z's, took 1, I got 1 left. Yes? You can have that little conversation with yourself in your head. Maybe not out loud. How do I know I'm on the right track? What tells me I have not, more than likely, I have not made a mistake? These are the same. I could not do the next step if these weren't the same. Why were we allowed to take a 5x out? What just happened? That was trippy. All right, spirits of the room, I am sorry.
Yeah.
What was it? Oh God, it's Mark. By the way, did anybody notice that day I made the title of the video not Math 171, I made it Mark 171? And I don't think anybody's read the description yet of that day. I think it was, you should read the description. It's kind of fun. All right. I could take a 5x out because they both have a 5, they both have an x. My next step is to take something out of these two, and I can't take anything out unless they're the same, and thankfully they both have x minus 2z. So I can take that out. So if these are not the same, you've made a mistake, or grouping won't work. So this will be, I can take an x minus 2z out, and I'm left with 5x plus 3z. And again, if you want to check yourself, before you wreck yourself, you can FOIL that out and see if it comes out to be the original. I love you guys. So again, I felt like we achieved a decent place with factoring, where it would come back to you, even if it had been a while. Is this true? Is this coming back? Okay, and I think I made it pretty clear. It's silly important in all the mathematics. Okay, do you want to do more factoring? You want to move to a different topic? Different topic. Okay. I'm going to leave it up to you guys. Oh, look at number 10. Just because.
Which one? Oh.
Number 10, the one about calculators. Very exciting world of calculator sales. Can anyone tell me, don't do it, but if you did graph this, what would it look like? If you did graph the profit function, what would it look like? Be very specific.
Exponential decay, what's it called? It goes down.
There's no e in there. There's no exponent. Right? Exponential means variable in the power. What's the highest degree? What's the highest power? Squared. So it's a squared, basically. What do those look like? They look like a u. Yes? Is this right, though? If I do this, is this correct? What is it about this that tells me this is wrong? Negative. So what should it look like? This. In which case, my head would be the max. And it would be the vertex. Yes? So if you have a quadratic function, its graph would be a parabola. If it's opening up, it's got a max that occurs to the vertex. If it's opening, if it opens down, it's got a max is at the vertex. If it's opening up, it would have a min at the vertex. Are you guys at all with me? So the vertex is where everything's happening, basically, for these kind of problems. How do I find that vertex easily? Do you want to put this into vertex form? Which means factor the negative 0.02 out and then do complete and square. Do you want to do that? I didn't say to do that, did I? You could do it if you want to. I don't know why you'd want to. Does anyone remember the shortcut to find the vertex?
Minus B, something over 2A.
That's it.
Just
Negative B over 2A.
Okay.
If we do,
That was such a struggle for me.
and real quick, can you guys remind me, just to remind you guys where this comes from? Just to see a lot of you guys with this kind of expression. What's the quadratic formula again? Negative B
It's like
plus or minus
E squared?
B squared. Now hit me with what you just said.
of the 4AC.
4AC, look at this, we're coming together.
Over 2A or
2A, pick X, right? What's being divided by 2A? Isn't this being divided by 2A and this being divided by 2A?
Yes.
Okay, negative B over 2A plus or minus blah over 2A, yes?
Yep.
Aren't I starting at negative B over 2A and going up by this amount and down by this amount? What does a quadratic formula do? What does it find?
Solve everything.
Yes.
If it did, we'd use it a lot more often. The only thing it solves is this,
Yeah.
specifically equal to 0, correct? How do you find the x-intercept of anything?
Set it equal to 0.
Set y equal to 0.
Oh, yeah.
Isn't that what this is?
Yeah.
So quadratic formula finds x-intercepts. Let me say this again. Quadratic formula more fundamentally solves this equation, but what does that mean for the graph of this thing? It finds its x-intercepts.
But sometimes give imaginary numbers.
Totally.
And there was like.
Totally. But we remember, were you here for
wasn't
that? You and Aubrey missed out. That's too bad. Someday I'll remember to put up again so you guys
He's
can watch.
referenced it so many times.
The
specifically
semester is
that-
over.
I know. I know. It's the way it goes.
It's hilarious.
This finds the x-intercepts. There's an x-intercept over here, and there's an x-intercept over here, yes? Even if it's imaginary, it happens on a different plane of existence, which these guys saw, and they recovered
I
from
think
it.
it worked.
It was pretty tricky.
It was pretty true. Real quick, if I know there's an x-intercept here and an x-intercept here, where's the vertex in relation to these two? Right in the
No.
middle. So what is always right in the middle of these two? That is, yes? Because how did I get to these two? Don't I start here and I add this much? And I start here and I subtract the same amount, correct? That is why. That is why the negative b over 2a thing is a shortcut to finding the vertex. So, the steps you have to go through with this problem. This is a parabola. I'm trying to find the max profit that would happen at this guy's vertex. How do I find the vertex? What's the shortcut? Negative b over 2a. Can anyone tell me what b is?
80.02.
80. And what's a?
Negative
Negative 0.02, yeah. And you could throw that in the old calculator, or even better, the negatives cancel. You get 80 over 0.04, which is 8,000 over 4. Or just plug in your calculator, right? I like that. So you get 2,000. What does that mean? What does 2,000 mean? What's that the value of? What did I start that string of calculations with?
That's the number of calculators.
Yes, that's X, and X is the number of calculators. So we figured out how many calculators we gotta make and sell. We gotta make and sell 2,000 to make max profit. If I make more revenue, but I also lose money to cost, to resources to make those calculators. The sweet spot is 2,000. How do I figure out what my max profit would be? That's easy. Not if I'm doing it by hand, but do I know what X is? X is 2,000. Do you have a formula for profit? So then I plug, that was interesting. Then I plug a 2,000 in and I get my profit, right? Okay, maybe. Does anyone remember negative b over 2a, or did my very quick explanation make any sense? Okay. back when we developed this, I actually started with finding the intercepts, and I said, where's the vertex? And we all said it's in the middle. So if I have an equation that gives me the intercepts, the vertex is in the middle. Okay. All right. Oh, by the way, maybe either in a little bit of time we have left or tomorrow we can focus on these kind of problems. Like, do you see 3, 4, and 5? 3 and 4 to go together. 4 is all about graphing this. And remember multiplicities and all that kind of business? Behavior at the roots, does it go through or bounce? That kind of thing, yes.
Oh.
And number 5 has got some of the same stuff. It's still graphing, but this involves asymptotes. Yes? Horizontal and vertical, that kind of stuff. So, do you guys want to have tomorrow focus on graphing? Like tomorrow we can do those, we can talk about transformations and stuff. And maybe we can focus on some of this from like number 6. There's a lot of logs down here, you guys notice that?
Yeah.
Yeah.
There's a few complex numbers. And to be really honest with you guys, complex numbers do not come up in calculus much. Not Calc 1.
What about Calc 2?
Calc 2, yeah, Calc 2, they come up.
Okay.
A little more, but not a crazy amount. But yeah, Calc 2, they definitely come up in one area in a big way. So this is more like just, we have to remember how complex numbers work. Can anyone remind me what I is? What is I? What is I all about?
Square root of negative 1.
Square root of -1. Yes? Do you remember this?
Mm-hmm.
So remember how I talked about the fact that it's, if you multiply by -1, you go 180 degrees. So if you start at 1,
Yeah.
you turn, you could become -1.
So I squared
So if
is
I-
1, or
Yeah, so I squared is -1. So if I go 90 degrees, that's I. And if I go another 90 degrees, it's got to be -1. So if I go I squared, if I go I twice, it's got to be -1. So I squared is -1. The most important thing to know in general about I is its definition, and that leads to I squared is -1. It is the first thing we've ever seen that when I multiply by itself, the answer is negative. Yes? Let's see. Do you guys, real quick, these are a little more complicated. This one's not that bad. This is brute force. How do you guys think we should do this one?
I would break it up into 3 parts
And then do the first 2,
yeah.
right? I always get somebody who, I don't know what they're thinking. They'll do this, and then they'll get an answer that's wrong, but they're doing this. I see this on the paper. I'm like, if I ask you, what is 2 times 5 times 7? Can you do all 3 of those at once? If you can, teach me. 2 times 5 times 7 is 2 times 5 is 10 times 7 is 70. You don't have to go a pair and then the next pair. So yeah, you're right. So multiply, foil these 2 out, let him just sit there and wait.
Mm-hmm.
Then your answer, foil it with this guy. Yes? I have no idea what these people are trying to do. Yes, and I don't blame them. It's a lot to remember. I get it, but it doesn't make any sense. Let's see here. What about the log stuff? Let's end up on this.
Just negative 3.
Beautiful. So remember, if I'm asking you for a log of 1 over something, what's the log base 3 of 27?
Wait, log base 3 of what?
Log base 3 of 27. Pretend like the 1 over is not there. Log base 3 of 27.
3?
3. Because the log asks you, what power does the base need to become the thing inside, right? Or how many of the base do I need to multiply to be the thing? Log base 3 of 27 is 3. So what kind of power makes it become 1 over 27? Negative power. So it's -3. Yes? So if log base 2 of 16 is 4, log base 2 of 1/16 is -4. I just need to make it flip, and then negative power makes things flip. Okay, so everybody freaks out about logs. Do you guys feel decent about logs? No. If you just remember the question it's asking you, the reason square roots are easier, because we don't even translate it into English. We just see it as English. We just see it and we know what a square root's asking us. You don't have to stop and go, what does it take 2 of them? No, you know the square root's asking you for that. You don't have to think about that directly. Logarithms, you don't work with them anywhere near as much. You have to remind yourself, what is it asking me for? What do you want from me, log? Yes?
But solving that, wouldn't we like raising that whole thing to 3 and cancel log 3 with 3 and then divide 1 by 27?
Do it again. I don't have an equation, so I can't do that much to it.
So, no, like,
So here's the question. So what do you ask me to do with it?
So, like, raise everything to 3?
So now you're changing the problem.
Why?
So if I had 2 fists and you said, okay, take it and multiply by 5, have you changed what I gave you?
Yeah.
Yeah. Now it's not the same anymore. Yes?
Okay.
Okay.
I would just ask them.
What you could do is say this equals I don't know, and then say, remember, put it into the washing machine. 3 to the x equals 1 over 27, yes? You could do that, because that's just reformulating the question. Remember the question that a log asks you is, what power does the base need to become the inside?
Yeah.
What power does the base need to become the inside, yeah?
Yeah.
Okay, yeah, you could rewrite it like that. I don't know if that's what you meant. You definitely can't cancel the log, because that's the whole question.
I mean, no, like normal solving logarithms. Wouldn't it be that? Like raising log, like, for like number, for D?
Yes.
Isn't that solving, or it's just different?
No, that is the problem that I'm given.
Okay.
So that 7 to the is already there. I didn't bring it in out of nowhere. It's there. It's part of the problem, right? This one I've got to think to myself, what do I raise 3 to get 27? 3, but how do I make it give me 1 27th? Flip it. Yeah. Yeah. Can you guys remind me, 7 to a power and log base 7, how are those related?
They can cancel each other out.
Why? What kind of functions are they?
They're inverse.
Inverses. 7 to the x and log base 7 of x are inverse functions. So if one is acting directly on the other one, they will kill each other. What is in the way? Stupid 2. Can I get the 2 out the way so these 2 things can kill each other? Civilized little math things. Kill each other. No? What can I do? Where'd that 2 come from? Somebody did something that it came from up here, right? So I'm going to put it back up there. Are these 2 now acting on each other
Yeah.
directly? So these 2
X squared,
kill each other. Answer is x squared. So you had to understand a property of logarithms where the coefficient can go back up in the power can become a coefficient, both ways. And you had to remember that 7 and log base 7 are inverses of each other. And of course, this problem deals with sure, but what's the idea behind E? No, it's not an equation. Yes. What's natural log of A plus natural log of B?
Is it A times B? Or just
Natural log of A times B. What's natural log of A minus natural log of B? Natural log of A over B. Yes? Because logarithms are powers. What do I do when I multiply like bases? I add the powers. So natural log of A times B is natural log of A plus natural log of B. I add the powers. So here I gotta do that backwards. Where can that 2 go? I'll tell you where that 2 can go. Be quiet. Where's that 2 go?
At the X.
Back up to the exponent. Then I have natural log stuff minus natural log of stuff. Do we have a property for that?
Yeah.
Yeah, I can divide the 2 things inside of a natural log, yeah? Okay. Do you want to do the problem, and that could be our last problem for today? So let's bring that 2 up. What can I do with these 2 LNs?
Set one over the other.
Yes, it'll be the ln of
X minus
the first dude
one.
divided by the second dude. Oops, sure, Jeff. That line is not division, that was just me underlining it, sorry. People always trip up with this. You see how there's a lot of shit going on in here? Do y'all agree with me? This is still natural log of stuff plus natural log of stuff, yes?
Yeah.
So what can I do with the stuff?
Set them to multiply each other.
I can multiply them, yes? Natural log of A plus natural log of B is natural log of A times B. Now, if you stop here, you're gonna lose some points, because is there anything I can do on the inside of that now? Now I've got all this stuff together, it can interact. What can I do with the bottom, for example? Factor it, dude. How do you factor the bottom?
X minus one, X plus one.
And then what's the one thing I can do?
X minus one cancels.
Yeah, I can kill one of these 2 x minus 1s up here and kill that guy. They'll kill each other. So I can cancel one of these, cancels with one of those. So then I just get ln of x times x minus 1 over x plus 1. So listen, this is fine. I'm gonna leave it up to you. I've got the answer key for the practice final finished. It could make sense for some of you guys to say, I don't want that yet, I'll get that tomorrow. So when I come to you, just let me know if you want one. If not, I'll have them again tomorrow. Okay, if you want one, you want one. You're like, you're the damn thing. No, you want one. Yes.
So that's the last thing we do.
Yes. No, not yet. And now it says, not for me. You won't. No. Raise it then. Unless it says, you didn't say that. The big one. Tomorrow, okay. All right, guys. I'm sorry. I'm tired today. Hopefully I made sense. So tomorrow we will cover whatever you guys want to focus on. Maria hopefully will be back. We'll see if she recovers well from whatever they had to do today. And we only have 2 more days, and then I might never see some of you guys again. I'll be all right. It'll hit hard on Wednesday.
Yeah, after we're gone.
Yeah. I was telling you guys at the math department meeting, I was describing 171. They were all very curious, and you know the other 171 teachers. We had a meeting last Thursday night, I think, discussing 171. Anything we want to change. We decided we didn't want to change too much about the notebook, except some little typo stuff. And the other 2 people teaching 171 are doing online homework, which I personally hate. I hate it.
Same. Like Pearson
Textbook
as
gives
well.
us structure. Even though this textbook is not the best, it's free, so it's automatically the best compared to paying stupid amounts of money for a textbook that has typos in it. But yeah, the overall thing I told them was this is one of the best experiences I've had in a long time with, but one of the best experiences I've had. And unfortunately, we're not going to be able to cap the course at like 13. So my next semester, right now I've got 5 people in there. I'm like, that'd be cool if I could just stay with 5. It could go up to 30, so we'll see. Oh, I almost forgot. I want to get your opinion. Do you guys remember when I asked you if you would be interested in writing a little something for my next semester students? I talked about it really quickly at the end of last week. I'm going to ask you, and I'm wondering if a Google Doc is not a bad way to do it. If I just send you a link to the Google Doc, if you can go in there, you'd be anonymous. You can just type in just whatever you want to say to the next semester 171 students. I thought it'd be a cool little bridge. Whatever you guys want to say, right, to my next semester, yeah.
Am I allowed to curse it?
Hell yeah. Okay. Please do.
I'll
in
do
fact.
with that.
You could drop little images if you want to, but don't, pretend like you're like terms of service or something, so to speak. Cursing's fine.
Oh.
Yeah. All right, guys. Let me know if you have any questions. Otherwise, I'll see y'all tomorrow, and we'll do all this again. Get
Same
ready.
class, just over again.
Yeah, we'll do all the same exact stuff.
I have a question
Yes.
Yeah.
See you guys.
about this sheet. So when you say like these scores, are you projecting future homework as well?
If you end up with none of the homework done,
Mm-hmm.
that's what your grade is right now. Does it make sense? You've done some of the homework, so you're not there.
Yeah.
You're somewhere between those two.
Okay.
And you know, like if you've done half the homework and half of it's good, you know, you're halfway between those two. Yeah.
Okay.
Does that make sense?
Yeah, so that's where I'm at now. And
Yeah.
that's not counting like homework that would be due by this.
Yeah, exactly. Yeah. I mean, I can only project so far because I'm missing the final, which is a decent chunk. So all the percentages are less than they should be.
Mm-hmm.
But this is a snapshot of now. So this is what I'm saying here, not including homework. That's what happens to that grade in these situations.
Okay, so looking at this, because this is what I need to pass. Oh, this is my most recent one, yeah. So I need to pass with like a 70, right?
Oh, no.
This is that.
Oh, thank God. Oh, please.
This is what I need to pass with the 70, like a regular pass.
Yes, exactly.
So if I didn't do any or turn in more of the homework, I would need like around here.
And again, this is if you end up having done none of the homework the whole semester.
Okay.
This is like your end, where you ended up. So if you're in between, you're in between.
'Cause I'm not sure how much homework I'm gonna turn in from missing it.
I mean, if you just want to pass,
Mhm.
you're in a great place.
Okay.
But I don't want you to just coast. I want you to try.
Trust me, I'm gonna have to try really hard because, like, even though these seem kind of low, I feel like with all of it combined, I really still need to lock in.
Understood. Understood. Yeah. And I mean, the nice thing is you can get yourself within range of a B minus pretty easy. Yeah.
Can I get an
If you, no. But just to show you, do you see how this is almost 40 apart?
A? Yeah.
So you'd have to add another 40 on top of this.
Okay.
Roughly. Less than 40, but still.
So I need 120.
100 something, yes.
Okay.
Yes. And I don't give that much bonus.
Noted.
But I mean, some people need 170 just to pass or something.
Mm-hmm.
In some of my other classes, or some people need negatives because they're already like, they already have like a 99 or something crazy.
Okay.
So it's a full range of stuff. You're in a pretty good spot.
That's reassuring.
Yeah.
Thank you.
What's up?
Mhm.